Okay, so let's consider. It's be a good thing for you to be taking notes on. Everybody got that?
Yes.
So if you got a notebook now, this would be the time to take it out and get ready. Notebook. Do you need one? Do you need a notebook? Joel, you need a notebook? Notebook, let's go. Okay, so last time I think we had the question on the board with the spheres, and we said this one's going up at 6, this one's going up at 4, this one's going up at 1. Did we talk about that? And we said which one's going faster after 1 second? And we talked about how if we use this equation right here, that would give us that information. Yes? Okay, so now let's consider if we're standing on top of a cliff and we drop a ball. We're just going to drop a golf ball off the side of a cliff. This is, by the way, this is what physics students do all over the world, is we drop stuff off cliffs and we throw things up in the air for no apparent reason. So that's what we do. We do a lot of that. We fire things with cannons. There's a lot of stuff. So V initial is 0. And let's walk through this. I'm telling you what you should be taking notes best you can with what you want. I would say write some things on the left side of the page that you know, kind of factual, and on the right side, start writing questions that you have. Like, hey, what about this? And then we'll go through those questions at the end. Okay? All right, so if I drop this thing, this is where I want you guys to understand something. At 1 second after it's been dropped, no. Oh, no. Wait a minute. We're missing that whole part about taking notes. Notebook? Notes? Somebody, help. Notebook, notes. We're writing things. Okay, so V initial is 0. 1 second later, see if you're sitting next to somebody who knows how fast that thing's going. Talk to each other. Figure it out. How fast you think that thing's going after 1 second? Okay. How many of you said negative 9.8? Beautiful. Can we just round that to negative 10? Makes the math a lot easier and a little easier to listen to. So we're going to say V at 1 second is equal to negative 10 meters per second. Correct? Okay, at 2 seconds, what is V2?
20 or negative 20.
Negative 20 meters per second. And then at 3 seconds, V3 is equal to negative 30. So this is no magical thing. We just know that it's increasing by negative 10 every second. So it goes from 0 to negative 10 in 1 second, then negative 20, then negative 30, nothing magic. We're not going to consider air resistance in here because we need calculus for that, and this is an algebra-based course. So this is introductory physics. It's not multivariable physics, so we're not there. Okay? No. The acceleration is negative 10 meters per second every second. So the acceleration is equal to, we're going to call that G. The special case for acceleration of G, of things that are freely falling, is negative 10 meters per second squared. Right? So that means negative 10 meters per second every second. Okay? So negative 10, then negative 20, then negative 30. Nothing magic. All right? Now watch this. What's the average velocity between these two? Negative 5. And what is that? What's the unit for that? Velocity unit? What's the unit for velocity? Meters per second. Meters per second. And how many seconds did it fall? 1 second. So how many meters did it fall? 5 meters. So the distance that it fell in the first second is 5 meters. So if you drop something and it falls for 1 second, 5 meters. Kind of cool, yes? Okay, real quick. What's the average velocity between these two values? No. The average between the two. We got negative 20 plus negative 10 divided by 2. 15. V average is 15 meters per second. How many seconds elapses between here and here? 1 second. 1 second between here and here is 1 second, right? So what distance does it cover in that second? 15 meters. Right? Right? Everybody with me? Now, what's the average velocity between these two? 25, negative 25 meters per second. Negative 15 meters per second. So 1 second interval, right? 2 seconds to 3 seconds. What's the distance that it falls? 25 meters. Add them up. Add them up. How far did it fall? 45 meters. So the whole distance it fell in 3 seconds is 45 meters. Okay, you ready?
45 meters over 3 seconds.
Correct. Watch this. What's the average velocity between here and here?
15.
So the average for the total is negative 15 meters per second. And how many seconds does it fall?
3.
V times T equals change in height. Negative 15 meters per second times 3 seconds is negative 45 meters. Because the per second and the second cancel out. So negative 45 meters. Okay, so we did the difficult part, like if we charted it all out, that's cumbersome. And then we did the top and bottom and average and multiplied by the number of seconds. That's pretty easy. Watch this. Change in height, 1/2 g t squared plus v initial t. What's v initial?
0.
So if something drops at v initial 0, what's half of g? If g is negative 10, what's half of that? Delta H is negative 5t squared. How long did it fall?
3 seconds.
3 squared is? 5 times 9?
So crazy. Why is no one else like it all right now?
Thank you for that. It is kind of cool though. So now you're on a bridge. You're on a bridge and you're going to drop a rock into the river and you're standing over the top and you look at your buddies and say, wonder how far up we are. And you drop the rock and it falls 1,001, 1,002, 1,003, 1,004, splash. 4 seconds. See if you're sitting next to somebody who knows how high up you are.
How high are you? Do you know? How high are you? Guys, give me conversation. Why did I give you conversation? What's wrong with them? I'm trying to figure out how tall they are. Okay, I'm tired.
Come on.
Class activity.
So you drop a rock off the bridge. It falls for 4 seconds and hits the water. And you go, I know how high we are. How high are you?
We are 70.
How many?
70.
Where'd you get that?
Because like it's this one and then
It's this right here. What's T? 4 seconds.
4 seconds.
What's 4 squared? 16 times 5. What's 16 times 0.5? In other words, what half of 16?
80. Oh, sorry, I added it. I did like how we were getting 25 and 15 and added those. I did the
What's the next one? 40?
40.
And 30 is 70, so half is 35.
Yeah, 35 plus 45.
35 plus 45 is 80.
Yeah, that's what I meant.
Yeah, it's 80 meters. How many of you got 80 meters? Perfect. Now you'll be able to impress your friends. Now, what happens if that same friend goes with you on a hiking trip and you're on a cliff area and you can't really just drop a rock straight down? Let's consider something like this. And you say, okay, I'm not going to be able to drop it straight down, but say my cliff, instead of being a straight drop like the bridge, is a rocky kind of setup like this. Let me build this out. And you're like, down here's a road, and you say, I wonder how far it is down to the road. See if you're sitting next to somebody who could figure out, how do you do that same thing we just did without, because your friend would probably just drop it and it'd bounce and that you'd never be able to do that, right? So see if you're sitting next to somebody who can figure out, how can you use that same technique and throw the rock in such a way so that you'll know how far up above the road you are. Does anybody have any idea? I don't want to set you off talking to each other if you have no idea. Okay, so here's a concept I want you guys to embrace. If you throw something with an exact horizontal velocity, what's the initial vertical of that? If I throw something straight out, what's the vertical V initial? 0, right? There's only horizontal velocity, no vertical at all. So if I throw it out this way with some velocity horizontal, some not greater than 0, let's just say that, and the velocity out this way clears the cliff and it hits, let's say the whole thing took 2.5 seconds. So 2.5 seconds later, it hits the ground. How high up is the cliff from the road? Down below. Discuss. Discuss, discuss, discuss. Let's say your horizontal velocity is unknown, but it's positive. It's not 0. We don't know how fast we throw it. We just know that we threw it horizontally, and it went over the rough, and it landed on the road 2.5 seconds later. That's what I'm trying to find. It takes 2.5 seconds for it to hit the ground. You throw it out here, it goes bam, 2.5 seconds later. How high up are you? Did you use 5t squared? 5 times 2.5 squared. So 2.5 squared is?
No, I did -5.
Well, your height is negative just because it's direction. Okay? What's 2.5 squared? 62.5? 6.25?
Yes.
So -5 times 6.25. 5 times 6 is 30, and then 5 times 1/4 is 1 1/4. -31.25. Yes?
Yes. That's correct.
Yeah. That's correct. So what assumption has to be made, Kevin? What assumption has to be made? How about the other Kevin? What assumption has to be made? If he threw it out horizontally and it worked out to be the exact same thing as if he dropped it straight down, what assumption can we make? FYI, here it is. The horizontal component does not affect the vertical component. I'll say that again. The horizontal component of the vector, velocity vector, does not affect the vertical component of the velocity vector. In physics, as a matter of fact, it is very rare, only on some occasions, and we'll talk about them later, very rare that the perpendicular items, forces, vectors, anything perpendicular, they happen simultaneously, but they do not affect one another. So it's a happening that's happening simultaneously, but one does not affect the other. So if I throw this straight out, the gravity right here it's experiencing is going to be the same as the gravity right here that it's experiencing, as the same as the gravity right here that's experiencing. Correct? So here's the really cool part. This is a logical experiment, just a thought process. Come on. Heads up. Up, up, up. Roy, come on. If I were to fire a gun completely level at the same time, fire a bullet, drop a bullet at exactly the same time, which one hits the ground first? Talk to your neighbor, figure it out. I'm firing a gun completely level to the ground and I'm dropping a bullet from this exact same height. Which one hits the ground first? Talk to your neighbor, ready, set, go. Okay. Let's do this thought process. Let's say I fire the gun up. Fire a gun up and I drop a bullet. Which one hits the ground first? Pretty easy. The drop. No problem. Right? Fire a gun up, drop a bullet, drop bullet hits the ground first. Every time. What if I turn and fire the gun down and drop a bullet? Which one hits the ground first? The fired bullet, right? I suppose there's some point in between where they're going to be same. This is Mr. Allen. I do. Okay. Yep, bye. Maddie, you got Jaden Vinion's folder or something? He needs it in the office. Okay, so if I fire the gun up, no problem, the drop bullet hits first. If I fire the gun down, the fired bullet hits first. There's some point in the middle where it's going to be the same. That's when the gun is being fired exactly horizontally. Same. That's to say the bullet going along is being affected by gravity here, and here, and here, and here. It doesn't take a holiday. Gravity doesn't say, oh, don't mind me, I'm sorry, you're moving, I see you up there, I'm going to ignore you for now. That doesn't happen. The mass of the earth didn't change. The mass of the bullet didn't change. It just happened to be moving horizontally. So the horizontal component of that vector has no effect whatsoever on the vertical component of that vector. You with me? So now, if I know it took 2.5 seconds to hit the ground, and I know that it happens to be, this is a happen to know, that it's 35 meters from here to here where it hits, who can tell me what the horizontal velocity was? Talk to your neighbor, figure it out. What can we say about the horizontal velocity? It is, starts with a C, constant. Constant speed. So we know the distance, and we know the time. Can we figure out what the velocity is? Come on, anybody. What is it? What's distance over time? Right. 14 meters per second? Does that make sense? So I wonder if we could figure out a different problem. Like, if I know how high something is, can I tell how long it takes before it hits? Okay, so let's ask that question a little differently. Let me erase just some of this. Okay, so we know our vertical V initial is same. Vertical V initial is 0. Let's let our horizontal velocity be 2 meters per second. So now we've got 2 meters per second horizontal velocity. We're 3.65 meters up. This is not drawn to scale. Matter of fact, let's just let the, instead of a person throwing it, let's just let it be a ball that rolls off. So a ball leaves the side of the table with a velocity of 2 meters per second. Okay. Okay, the height is 3.65 meters that it falls from. What's V initial vertical? What's vertical V initial of this thing that rolls horizontally off the table? 0. So no vertical, right? It's just all horizontal. Okay, so when you're figuring out these, this is called motion in 2 dimensions. It's going X and it's going Y. So we've got 2-dimensional motion. 2-dimensional motion has nothing to do, one has nothing to do with the other. In other words, the X does not affect the Y does not affect the X. However, they are happening simultaneously. So we call it 2-dimensional motion. And then in that respect, you got to realize you need to divide this problem into 2 parts. The vertical happening and the horizontal happening. So horizontally, what is happening? It's going what? Horizontally, it's going what? 2 meters per second. So the velocity is constant 2 meters per second. Yes? So if I were to draw a vector, diagram, it would have a 2 meter per second vector and a drop. And then the same 2 meters per second and a drop. And then the same 2 meters per second and a drop. And the same 2 meters per second and a drop. And the same 2 meters per second and a drop. So you see what's happening? Same 2 meters per second and a drop. So this is getting larger. What does that mean? It's increasing, it's accelerating downward. We knew that. We even know the rate at which it's accelerating, yes? What's the rate at the acceleration?
-10 meters per second.
Negative 10 meters per second, right? Okay, so it's accelerating at negative 10, but this is 2. What's the horizontal velocity as it hits the ground? 2. It's 2 the whole time. The horizontal stays constant. Now, let's revisit that for a moment. Why do you suppose the velocity on the horizontal stays constant? Roy, stay with me. Why do you suppose the velocity stays constant? Huh? Why are you supposed to velocity horizontal stays constant? Huh? Who remembers Newton's first law? An object in motion stays in motion, or an object at rest stays in rest. In other words, objects and their state of motion stays the same until it's acted on by an unbalanced force. What do we know about the force? Must be balanced. Because the thing goes constant, steady, steady, steady. So here's the thing. The reason it stays steady, steady, steady is because nothing's changing it. Why does it speed up? The vertical. Because it's being pulled by gravity. Right? There's a massive attraction. Universal gravity. We're going to get to that. But it's pulling on it all the time. On everything. Right? That doesn't stop. And it's pulling on that thing vertically as it's moving horizontally. They are unrelated. They're just happening simultaneously. Okay. So, 3.65 meters in the air. How long does it take to hit the ground? Work it out. Work it out. Work it out. How long does it take to hit the ground? 3.65 meters up. How long does it take to hit the ground? Casey. How long does it take to hit the ground? Are you not feeling well? Huh? Can we send you to the clinic? How long does it take to hit the ground? Madison, did you already go to the office? Okay. Gotcha. So 2h over what? What's the formula that guides our thinking for the time? What do we know? We know the height. We know the initial vertical velocity. Vertical v initial is 0. Correct? Acceleration is negative 10 meters per second squared. Correct? Height, change in height is negative 3.65 meters. Correct? Right? Change in height starts up here, ends up down there. So it's negative. Final is 0. Initial is wherever we are. Final minus initial. 0 minus 3.65. Negative 3.65. Writing this down? You writing this down?
Wait, are we finding the...
When you write stuff down, your brain stays engaged. You don't doze off. Movement. Movement makes for better brain processing.
Are you asking for the final velocity?
No, I want to know how long does it take? How long does it take to hit the ground? So V da 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 da, and then T is our question mark. What formula has all this in it?
Distance over velocity.
Delta H equals 1/2 GT squared. We can solve for T because we don't know V final. So we can't use the acceleration one.
But wouldn't the H be 3.6?
Delta H is negative 3.65. What's half of G?
0?
Half of G? G equals negative 10 meters per second squared. What's half of that? G is negative 5. T squared. Can we solve for T, people?
Yes.
Can we do it?
Yes, we can.
Divide both sides by negative 5. Negative 5. Right?
So how did you know to use that?
Because I looked at the list. And this list says V initial, A, delta H, and T. And that's the only one that has that. Delta H, A, T, V initial. Nothing else has that collection of things. So you look at your situation, you write down, you write down the one you're looking for, match it up to a formula, and plug it in. And then after a while, you get really good at recognizing. And then you go, oh, I know what formula we're using because it's da-da-da-da-da-da. But at first, it feels a little awkward, right? And if you're still in the awkward stage, totally understandable. But right now, this is the formula. What happened to the V initial? It's 0, so I left it off. Do you need a pencil? Is that what it is? I thought you were trying to write with a golf ball. Okay. Just give me a minute. Roy, what's the question? Okay, so how long does it take? $7.3 seconds? 0.73 seconds. How do I know it has to be less than a second? How do I know you did not? Oh, that's not it. What's the square root of that? 0.854. Now, real quick, how do I know it's less than 1 second?
Because it's 10 meters.
5 meters is 1 second. So this is less than 5 meters. So it better be less than a second, right? 5 meters takes 1 second to fall. If it's less than 5 meters, it better be less than 1 second. Almost there. Did you create a pass already? You work on that, and then when I'm ready, I'll approve it, and then you'll know you're ready to go. So if my time is 0.854, whoa, people! Who can tell me how far away it lands? What's the horizontal speed? Jackson, what's the horizontal speed of this thing? 2 meters per second. How long is it traveling for? So what's the distance? $1.78? $1.7? So the distance is 1.7 meters away. Everybody follow that? I'm going to give you a new question, and then I'm going to give you a lab activity. We're almost out of here, so you can't do the lab yet, but you'll be able to set it up and know what you're doing. Okay. Here's the setup. Yeah? Did you send me a pass? Okay. Ball rolls down the ramp. Rolls off the table, which is 76 centimeters high. It lands 43 centimeters away on the floor. What is the exit velocity of the ball off the table? You can